Kubernetes services and orchestration of the application workloads, while the actual application workload runs on the node components. In Azure Kubernetes service, the control plane is automatically created, configured, and managed by Azure. There are four main services running in the control plane. Kube API server is how the underlying Kubernetes APIs are exposed. This component provides the interaction for management tools such as kubectl. Itself is used to maintain the state of a Kubernetes cluster and its configuration. This highly available service is a key value stored within Kubernetes. Controller manager oversees a number of smaller controllers that perform actions such as replicating pods and handling node operations. When you create a set of applications, the kube scheduler determines what nodes can run the workloads and starts them. On the agent node component side, we have kubelet, which is a Kubernetes agent that processes the orchestration request from the control plane and schedule the requested containers. Virtual networking is handled by kubeproxy on each node. The proxy routes network traffic and manages IP addresses for services.
हाँ बस इसमें रख के थोड़ा थोड़ा दबा दीजिए मैं ले
Container
लेता हूँ
runtime is a component that allows
हम्म
containerized applications to run and interact with additional resources such as virtual network and storage. Now that you know some of the components and their high-level functionality, let us see how these components talk to each other when you issue a command to create a new Kubernetes environment. Do not worry, it just ends up looking very complicated. You will not need to remember all of this. Just remember, there are multiple subcomponents with very well-defined function for each of them. In step 1, kubectl is a pod deployment manifest to the API server. The API server then creates a deployment resource, and that info is saved in Consid. Deployment controller watches for any new deployment resources and creates the replica set resource. Then, replica set controller watches for any new replica set resources. Replica set controller creates the pod resource based on how many replica set and actual pods are present. In steps 6 and 7, kubectl watches for unbound pod resources and schedules them on a target node. Then, kubelet calls container runtime interface and container network interface between the pod and container network configured. Steps 9 and 10, CRI calls host network layer from the pod HCS to create container and host networking service called HNS to create the endpoint. Finally, in steps 11 and 12, kubeproxy watches for any new endpoint and programs HNS with load balancer and access control list. Now that we have covered some of the Kubernetes fundamentals, let's start deploying a cluster in Azure. In this demo, I will show you how to deploy a KS cluster using Azure Portal. You can follow along if you have a subscription handy or take the labs that follow. On the Azure Portal, I will click on Create a Resource and then select Containers category on the left. As you can see, there are quite a few services under Containers category that Microsoft offers, apart from many more from marketplace offerings. Now, under Azure Kubernetes Service, I will click Create. Since this is a brand new subscription, I will AKS1 dash code cloud app. This name has to be unique in this resource group. I will then change the region to Southeast Asia, that is Singapore. Since this is not a business critical app, and because I want to save some money, I will uncheck all availability zones. When you select more than one AZ, Azure will spread the nodes in the node pool across availability zones, providing higher availability. You should of course do this in your production environment. One thing to note on AZs is that not all regions has availability zones. For example, if I want to select Australia Southeast, there are no AZs to select. Alright, let's go back to Australia Southeast and uncheck all availability zones. I believe the default version of AKS, which as you can see is the mid version in the list. The Kubernetes community releases minor versions roughly every 3 months. AKS follows 12 months of support for a general availability Kubernetes version. So version 1.24, which went GA in July 2022, will be supported for 1 year from that date. Microsoft does provide a pathway to upgrade deployed AKS clusters. I will leave the default node size to DS2. In module 2, I talked about various VM sizes available in Azure. This one has 2 vCPUs and 7 GB of memory. Let's set the node count to 1. This will give me an opportunity to show you how to scale it up later. Click next. Since we have set the node count to 1, node pools show that as the maximum. That is, the minimum is set to 1 and maximum is also set to 1. If I were to go back and change the max to 5 and click next, you will see that reflected here. Also note that the max pods per node is set to 110. If you need to add more than 110 pods, you will need to add more nodes. This, by the way, has nothing to do with VM size. You can select a VM with 32 core CPU and 128 GB of memory, but the pod to node ratio is between 30 to 250, which can be configured if you click on the agent tool. Let's set this to 30 and click update and then next. Let's set this to 30 and click update and then next. In the authentication and authorization pane, you have 3 options to select from. You can leave the default here and move to the next tree. I will discuss this option in some detail in the next module. In the networking option, select Azure CNI. Since I do not have any existing virtual networks, I will let Azure create one for me. Do not worry about what these options mean. The network configuration and network policy are important settings, and I will discuss them in the next module. For now, let's click next. We will take this opportunity to create an Azure Container Registry. Container Registry is a managed service that is based on an open source Docker registry. This can help you store our container images like the one we created in the previous module securely and privately. I will give it a name, use the same resource group and region. I will choose a basic SKU. SKUs in container registry is about higher performance and ability to replicate across the globe. Since we do not need all that jazz, let's select basic and click OK. Let's enable container logs and let the logs go to this new log analytics workspace that Azure is creating for us. And yes, we will come back to monitoring later. Click next to go to advanced break. The infrastructure resource group is where all the infra related to AKS like networks, VMs, etc. are created. Microsoft recommends to leave the defaults, but in your production environments, you can change it with the naming policies required you to. We will click next and leave the tags blank for now. If you have used any cloud platform before, you know what tags are. If not, you can ignore these for now. In the next screen, Azure runs a quick validation to see if all the required options are filled and if we can continue with it. Once the validation is complete, let's click create. In the last demo, we had deployed an AKS cluster along with some prerequisites like resource group, virtual network, etc. In this demo, we will connect to that
Caller.